Imagine a world without light, without communication, without the comforting hum of electricity. Our modern world, a tapestry woven with the threads of technology, suddenly unraveling. This is not science fiction, but a stark possibility, a threat from a seemingly benign star, our very own sun, the culprit, solar storms. These celestial events, capable of unleashing the energy of billions of atomic bombs, are a stark reminder of our place in the vast cosmic arena. While the sun sustains life, it also possesses the power to disrupt it in ways we are only beginning to understand. The sun, a churning ball of plasma, is a constant source of energy, some of it life-giving, some of it potentially destructive. This massive star at the center of our solar system is not just a static, glowing orb. It's a dynamic and ever-changing entity, constantly undergoing complex processes that can have far-reaching effects. The sun's surface is a boiling cauldron of activity, with plasma swirling and magnetic fields twisting and snapping. These magnetic fields are particularly important because they play a crucial role in the formation of solar storms. Solar storms, often triggered by intense magnetic activity on the sun's surface, are powerful eruptions of energy and matter. These storms are not just random events, they are the result of the sun's magnetic field lines becoming tangled and then suddenly snapping into a new configuration. This process releases a tremendous amount of energy which can then be hurled into space. The energy released during these storms can be equivalent to billions of atomic bombs exploding simultaneously. These eruptions can take various forms, the most notable being solar flares and coronal mass ejections, or CMEs. Solar flares are sudden, intense bursts of radiation that can affect all layers of the solar atmosphere. They are often associated with sunspots, which are temporary phenomena on the sun's photosphere that appear as spots darker than the surrounding areas. CMEs, on the other hand, involve the release of plasma and magnetic field from the solar corona, the outermost part of the sun's atmosphere. Solar flares are intense bursts of radiation, like sudden flashes of cosmic lightning. They can release a vast amount of energy in the form of light and heat, and they can also accelerate particles to near the speed of light. These flares can have a direct impact on Earth, particularly on our communication systems and satellites. When a solar flare occurs, it can send a stream of high-energy particles toward Earth, which can interfere with radio signals and even cause damage to electronic components in satellites. CMEs, on the other hand, are massive eruptions of charged particles, 1 billion tons of solar plasma hurled into space at incredible speeds. These particles can travel at speeds of up to several million miles per hour, and when they reach Earth, they can interact with our planet's magnetic field. This interaction can cause geomagnetic storms, which can disrupt power grids, navigation systems, and even cause beautiful auroras, also known as the northern and southern lights. Both phenomena can have significant impacts on Earth, particularly on our technology-dependent society. Solar flares and CMEs can affect everything from GPS systems to power grids, and even pose a risk to astronauts in space. Understanding these solar storms is crucial for predicting their occurrence and mitigating their effects. Scientists use a variety of tools, including satellites and ground-based observatories, to monitor the sun's activity and provide early warnings of potential solar storms. By studying the sun and its behavior, we can better prepare for the challenges posed by these powerful natural events. The annals of history whisper tales of the sun's fury. These tales, often buried in the pages of ancient manuscripts and historical documents, reveal the immense power and unpredictability of our closest star. From the earliest observations of sunspots to the detailed records of solar flares, humanity has long been fascinated and sometimes terrified by the sun's behavior. In 1859, the Carrington Event, the largest solar storm ever recorded, showcased the raw power of our star. This monumental event was named after the British astronomer Richard Carrington, who first observed the solar flare that preceded the storm. The flare was so intense that it was visible to the naked eye, even in broad daylight. The subsequent geomagnetic storm was unprecedented, lighting up the night skies with auroras that were visible across the globe. Telegraph systems, the cutting edge of communication at the time, went haywire, sparking fires and delivering shocks to operators. The storm induced electric currents in telegraph wires, causing widespread disruption. Some telegraph operators reported being able to send and receive messages even with their batteries disconnected, purely from the electrical energy induced by the storm. This phenomenon highlighted the vulnerability of our technological infrastructure to solar activity. The aurora borealis, typically confined to high latitudes, painted the skies as far south as the Caribbean. People in regions that had never seen such displays were awestruck by the vibrant colors dancing across the sky. Newspapers at the time described the auroras as so bright that people could read newspapers outdoors at night. This extraordinary event left an indelible mark on the collective memory of those who witnessed it. More recently, in 1989, a solar storm plunged the entire province of Quebec, Canada, into darkness, disrupting power grids and causing widespread blackouts. This event demonstrated that even in the modern era, our advanced technology is not immune to the effects of solar activity. The storm caused a massive power outage that lasted for 9 hours, affecting millions of people and causing significant economic losses. It served as a stark reminder of the potential consequences of space weather on our daily lives. These events, though separated by time, serve as stark warnings, reminding us of the potential consequences of underestimating the sun's power. As our reliance on technology continues to grow, so too does our vulnerability to solar storms. Scientists are working tirelessly to improve our understanding of solar activity and to develop better forecasting methods. By studying past events like the Carrington Event and the Quebec blackout, we can better prepare for future solar storms and mitigate their impact on our world. The worst-case scenario of a massive solar storm hitting Earth today is a sobering thought. Imagine a world plunged into darkness, not for hours or days, but for weeks, months, or even longer. Power grids, the arteries of modern civilization, would collapse, leading to cascading failures in communication, transportation, and essential services. Satellites, our eyes and ears in space, would be rendered useless, their delicate electronics fried by the onslaught of charged particles. Financial markets would grind to a halt, supply chains would crumble, and the world would be thrust into an unprecedented state of chaos and uncertainty. Guardians of the solar system, tracking the sun's fury. Fortunately, we're not defenseless against the sun's temper tantrums. Scientists around the world, using an array of ground-based and space-based observatories, are constantly monitoring our star, tracking solar flares and CMEs with increasing accuracy. Spacecraft like NASA's Parker Solar Probe and ESA's Solar Orbiter are venturing closer to the sun than ever before, seeking to unravel the mysteries of its magnetic field and provide crucial early warning of potential solar storms. Shielding our world technological countermeasures. Beyond monitoring, scientists and engineers are developing innovative solutions to mitigate the impact of solar storms. Hardening power grids, making them more resistant to the surges of energy induced by solar storms, is a top priority. Developing shielding technologies for satellites, protecting them from the damaging effects of radiation, is another area of active research. Furthermore, researchers are exploring ways to improve space weather forecasting, enabling more accurate predictions of solar storms and giving us more time to prepare. If the storm hits, a guide for preparedness. While governments and space agencies are working to protect our infrastructure, there are steps we can take on an individual level to prepare for a potential solar storm. Having a plan for communications, securing a supply of essential items like food, water, and medicine, and knowing how to protect electronic devices from electromagnetic pulses are all prudent measures. Just as we prepare for other natural disasters, so too should we be ready for the possibility of a solar storm, however remote it may seem. The indomitable spirit, our legacy of resilience. Throughout history, humanity has faced countless challenges, from natural disasters to pandemics to self-inflicted crises. And yet, time and again, we have shown an uncanny ability to adapt, innovate, and overcome. The threat of solar storms is real, but it is not insurmountable. We have the knowledge, the tools, and the collective will to face this cosmic challenge head-on. A future forged in the stars, facing cosmic challenges together. As we venture further into the cosmos, establishing a permanent human presence on the moon is not just a dream, but a necessity. The moon serves as a stepping stone, a proving ground for technologies and strategies that will be essential for deeper space exploration. Building lunar bases will allow us to test life support systems, resource utilization, and the psychological effects of long-term space habitation. Mars and beyond, our understanding of and preparedness for space weather will become even more critical. The red planet, with its harsh environment and distance from Earth, presents unique challenges. From radiation exposure to dust storms, every aspect of a Mars mission requires meticulous planning and innovation. The knowledge we gain from these missions will not only help us survive on Mars, but will also enhance our ability to protect Earth from similar threats. The challenges posed by solar storms are not just technological. These powerful bursts of solar energy can disrupt communications, damage satellites, and even affect power grids on Earth. Understanding and predicting solar storms is crucial for the safety of both astronauts and our planet's infrastructure. Advanced monitoring systems and international data sharing are key components in mitigating these risks, but also social and political, requiring global cooperation and coordination. Space exploration is a unifying endeavor that transcends national boundaries. Collaborative efforts among international space agencies, scientists, and policymakers are essential for addressing the multifaceted challenges of space weather. By working together, we can develop comprehensive strategies that benefit all of humanity. In facing this cosmic challenge together, we not only ensure our survival but also foster a spirit of unity and shared purpose. Diverse teams of scientists and engineers bring unique perspectives and solutions to the table, enhancing our collective ability to tackle complex problems. This collaboration extends beyond the scientific community, involving educators, students, and the general public in the excitement and importance of space exploration, but also forge a stronger, more resilient future for all humankind. The technologies developed for space missions have far-reaching applications on Earth, from improving medical treatments to advancing renewable energy sources. By investing in space exploration, we are also investing in the future of our planet, creating a legacy of innovation and resilience, a future where our reach among the stars is matched by our wisdom and preparedness. As we establish human settlements on other planets, we must do so with a deep sense of responsibility and foresight. Wise leadership and ethical considerations will guide our actions, ensuring that our exploration efforts are sustainable and beneficial for all. Together, we can turn the challenges of space into opportunities for growth and discovery, paving the way for a brighter future among the stars.